Hello, this is Jose Cepeda and this is video quiz walkthrough number 8. And in this problem we were asked to find the current through the resistor and a capacitor with given parameters. And in this case we have a voltage with respect to time of 100 cosine 60t plus 20 degrees volts, and this voltage is going through a 40 kilo ohm resistor and a 50 microfarad capacitor. And the first thing that I did was to draw my circuit and determine my current going through and splitting at node A. And then the second thing that I did was to break down my elements, and I had an amplitude of 100, an angular frequency of 60, and a phase shift of 20 degrees, and then I converted that into a phasor form of 100 and of 20 degrees. And since per Ohm's law, to find the current through a resistor, that's very simple, which is voltage over resistance. And in this case I just calculated the in phasor form 120 degrees over 40,000 ohm resistor. That gave me a current through that particular resistors in phasor form of 2.5 and 20 degrees milliamps, and that's just the current through that resistors. And then the next thing was to determine the current through the capacitor. And since I have a sinusoidal function, and according to lecture I could have determined that with the voltage current relationship of current equals capacitance times the derivative of the voltage over time in respect of time. But I decided to simplify things by also utilizing Ohm's law, which is current equals voltage over resistance, and in this case it was voltage equals impedance. Yes, impedance, and the impedance through a capacitor is equals to 1 over the imaginary number angular frequency times the capacitance. So then after some algebraical manipulation, it's current equals voltage times the imaginary number of J equals the square root of -1 times the angular frequency times the capacitance. And then I inputted my values, and my voltage is still in phasor form, and the current through the capacitance was 100 and the angle of 20. And since the imaginary number J is equals to 90 degrees, and I was a little bit confused about that, but after a little bit of research, well, J equals 90 degrees, which can be added to my phasor. And then I continue to input my values of angular frequency of 60 times 5 to the -6 farads, converted from microfarad to farads. And after all of that, it yield a current through capacitor of 50 milliamps, The current was 0.3 to the angle of 110 amps in phasor form. And then I decided to convert my current to sinusoidal form, and that was just basically the current through the resistors of 2.5 cosine. And since the frequency did not change, because if the frequency changes we have to recalculate the whole thing, so the frequency remains 60 with respect to time, plus 20 degrees milliamps, and the current through the capacitor was 0.3 cosine 60t plus 110 amp. The 110 was the addition of the original 20 degrees plus the imaginary number. And that's basically how I decided to approach this problem. Thank you.